Hello, hi, how's it going? We're back with a properly set up agenda this time. Last time I accidentally pressed the go live button when I did not plan to. But today I did not click the wrong thing, so good job of me. I'm a little bit tired today, but that's okay because I have written myself an agenda. Right. We're gonna do about 3 things. We're gonna do the lifter mechanism, we're gonna design a bin, and we might make the camera mount for the thingy. Now I think I did show you. Hold on, let me get a new window. Oh wait, cancel file. No, okay. I can just open a second window of paint. Wow. So this is what we've got so far. Might not zoom out. I guess not. That's cool, I guess. Anyway. Yeah, that's not helpful, is it? Well, okay. We're gonna do it a little bit differently then. Let me fix the size on my thingy, and then instead, here's what we're gonna do. I'm going to click this button, I can click this button, and then I can click this button, and then I can click that button, and then I can click this button, and then wow. Incredible, there it is. Anyway, this is what we got done on last stream. We designed the card bin holder tray and the bracket that, you know, assembles it all and put it all together off stream. But if you see in the bottom right corner, hold on, let me add something real quick. File, new image. Yeah, we'll resize that to be like 30 by 30. That sounds about right. Yeah, that's a good size. And then here, let me cook. Okay, let me cook. Let me cook. I'm cooking, chat. I'm cooking. Give me one moment. There we go. All right. I just need to draw the outline, and then there we go. This can go into the picture. Okay. And then check this out. Check this out. Wait, where did my folder go? Oh, here it is. Boom. Where'd it go? Oh, there it is. Okay, anyway. So this here is the camera. So that's what we need to, that's what we might do a mount for. I can also do a mount for this, but what we need to do is we need to design the thingy that goes up and down on, this. That's the linear rail carriage, right? So I need to, have that go up and down. But yeah, other than that, pretty sure that is all. Got the most cursed cursor here. It just snaps to stuff, but that's okay. Yeah, I don't know. I can hide that again now. Yeah. So how about we just hop into Fusion 360 and work on stuff. Boom. Check that out. And we don't need Firefly. I get latest. How do you do that? Get latest in the design workspace. That's where I am. Oh, I clicked something and it worked. Cool. Anyway, let's figure out the measurements for the grabber, shall we? Okay, let me see how far off, because we are using an MGN. I do actually need Firefox. An MGN 12C is what we are using. I see like the, I guess. Oh, right. I should have this over here so it's not doubled. That's not helpful. Okay, here's the information. Go away. Okay. So basically, we have it be H off of the rail, and H is 13, so it's 13 tall. You know what, I might just have it be at the center of this thing. So it's from there to there. So that would be... Which one would be center? Well, maybe I'll just go to... Oh, so it's 80. So this is what half. Oh, it's this one, right? No, I'm bad at doing things. Not that. No. And it's not this. Yeah. In between those two. Very nice. That's okay. Here, I need to lock in. And we're just gonna do it the lazy way. Good old fashioned do that and then just Alright, now how wide is our block? That would be L, I believe. So how long is L? Where's L? 34.7. We're just gonna round that up to 35. That's not right. I have one in real life. Oh, I guess it is 30. Okay, sure. And the other dimension is like 27 or some silly number like that. I can see that right there. That's W27. Wow, I was right. My measurements are immaculate. Anyway. Now, we determined our H is... I believe that is? Yeah, 13. New body. Okay. This is just gonna be our linear rail. We're just gonna call that a linear rail. It's probably fine. And so I have another linear rail. It's like 200 and I think it's 200. And that will go up and down, so. Oh gosh, I am tired. Yeah, okay, so we'll have a linear rail attached to this somehow, and then that linear rail will go up and down to I need to think of the best method to attach it though, because like I don't know. Do I just? No, that's really dumb. Like, I'm thinking I could just like have a. Let's do a little bit of research, shall we? Let's do some research. Also, why is Firefox above chat? Does not need to be like that. Alright. What do we Google for this? 3D printer linear rail. Why is caps lock on? What was that patink for? I got a click. Was that me in Google? Did I get that for pressing this? Wait, am I being extremely stupid right now? I feel like that's... What was that sound from? That's cool, I guess. Well, it doesn't matter. So let's see how do like most CNC machines like do it, you know? Like here, this is a good example. So it seems that it's just like a plate, which I mean, but the thing is I need to attach my linear rail to a linear rail. So how is this the least resolution image I could have possibly picked? Because how do you like interface two linear rails next to each other so that it's not like bad or whatever? Here, let's see. Yap. I don't care. Okay. I mean, it just seems like you just grab it and hold it onto the side, so we're just gonna do that, you know? Boom. And watch this. You didn't see anything. Anyway. Should I have the linear rail face the other direction then? Would that be easier? Well, that's not as important as the actual part that like contacts the cards though, so we can actually do this first. So, it's our card size is 65 by 90 if I remember, or 65 by 90. Yeah, okay. So for the grabber part of the machine, we will just do 60 by 85. I think is a good number. So 60 by 80. Oh, that's not. There we go. 60 by 85. Wow. And then this is just, we can always change this later. I'm just, for the first one, I'm just gonna have it be a 5mm like contact point. I think is probably fine. And then it probably only needs to go up about a centimeter, I'd say. Let's create a sketch here. And I need to figure out how to best what's it called? How to best actuate this up and down. Like, what's the best linear motion system that I could incorporate? Preferably one with as little friction as possible, but of course, you know, that might not be possible. I like how I'm just accomplishing, like, okay, I need to go and get my, the suction cup. So that I can figure out what dimensions I need for all that, so let me go do that real quick. Sorry, I thought I muted my microphone and clicked the mute button, but I didn't. Oh well. I'm like the worst streamer on the planet, dude. What is this? Oh, that's a MOSFET. That's cool. This is not this is not going well today. We are not popping off like we were. Well, I wasn't popping off that day either, but like I was at least not the most boring person on the planet to talk to, you know. But alas, I need a way for my thingy to go up and down. That is it. It should be a fairly simple, like what if I just had the 3D print sliding on the 3D print, right? Like what happens there? We can just do that. We'll just do that for now, and if it doesn't work, it doesn't work. Then we have to design something for real. But if I don't have to design something for real, I will try my best not to design something for real. So now we have to decide what is the like profile of that. I'm going to make it so that it prints in this orientation. So we're gonna have the sliding section here and here. I mean, for now, we can always just start with a simple, like, dovetail kind of deal. Just like one of these. Like, that should just do it. And then we mirror that on the other side. Here, let's try that. So how far up does it need to go? It needs to go up about like... We're just gonna make it be 20. No, actually we'll make it be 30 because then we can have two whatever's of whatever. Sorry, that was not very explanatory. Gosh, I'm so boring to listen to. What am I doing? I'm just spinning this in a circle. Let's keep going. Let's make another sketch. No. What if we didn't do the dovetail thingy? We don't need to necessarily have one. We can just have it be straight and it'll be fine. It won't be a big deal if it's a little bit cringe. Because what I need to do, I just need to make something that exists. And then once I make something that exists, I can move on to making something that's good. It doesn't need to be that wide. It does not need to be that wide. Okay, I need to think about the best way to make this printable. I know. Don't make it that wide. We actually just... We start from... Here's what we can do. Make something printable. We will just... Curious. What do you do? Maybe I shouldn't be, because I hadn't thought this through at all. I was like, surely I can just think this through on stream, right? But no, I can't think at all. So, it's not going well for me today. I don't know, yesterday I was out and wandering around and with some friends. And I think that took my energy that I was supposed to save for today. Tomorrow I have work. So I'm cooked, question mark. But anyway, here's what we can do. Make it work such that you can actually print it. We can start it like this. And then that. That'll be printable. And then we can extrude that 40 millimeters. Okay, let's extrude it actually 45 millimeters. What if we just extruded it like 50 though? 50. Yeah, 50 I think is fine. And then if I wanted to, I could have tracks in there that I could put some slippery materials into, or maybe even ball bearings, but I don't know like what I'd do about that. Anyway, let's go and do the let's do the part that slides in with that then. Let's make another sketch from here. Now the real question is, how do I keep it such, well, does it not, it doesn't need to not wobble. It's completely okay if it does wobble a little bit. So, you know what? We're just gonna copy the profile and just like press pull it in a little bit. Really, there's a better way to do this, right? But whatever, I don't really care. Wow. We're gonna make it minus 35, I think. Yeah. We're not joining, we're new bodying. Oh yeah, and then I need to make a hole in it as well. Although this one is the one that we're gonna mount the suction cup onto, so let me figure out exactly how high up the interface is. Not interface, but the there's a point where you mount the screw, and it seems to be at about 30, but we can, no, it's at 35. We're gonna say that's 35. So 35 up from here. So we need to take 35 up. Create a sketch. And then we'll just say that is where it mounts. Sure, we'll call that good enough. Like, I just need a reference point, really. Maybe I should have just made it symmetrical. We're gonna make it symmetrical, actually. That was pointless. There we go. Now it's symmetrical. At the very least, we need to make it symmetrical. Where is it? Sketching. Okay. So at the 35 mark is when we okay, I see. So that is when we put our M10 section into. So we're gonna make this 11. So it can be, oh, I'm not actually done with that sketch. And then beyond that, we make it bigger on the outside. Actually, we can match this. So let's go grab our sketch. We can extrude this way. I need to see that again. And we'll have this go the other direction. Alright. Now let's see. I don't actually need to worry about that right now. So we're just gonna have another round section that's just bigger again. It doesn't need to be that much bigger, but it does need to be a little bit bigger. Or maybe I make it the same size as the hex and then I just screw in the thingy. I feel like that it's probably easier if... No, you know what? One of them does need to have the hex profile. I think it would be easier if I made the part for the suction cup have the hex profile though, so I'm going to make this one the big round one. We're gonna make it 40. 40 is just the consistent number here. And then we need to move it. I would like to have 7.5 millimeters here, so negative 20 plus 7.5. Well, that good. And then I don't need this sketch anymore. What I do need to do is create another sketch here. And then here I'm gonna make a hexagon. And I need to figure out how big I need to make this hexagon. I don't have a calipers, so I literally have to eyeball everything, which is not the best way to do things, you know. But I believe if I take a inscribed hexagon at 12 millimeters, that's the same. No, a circumscribed. Yeah, a circumscribed hexagon at 12. We're gonna go up to 12.5. I believe that's the same size as this thing. I extrude that and then extrude this down a little bit. Actually, it can be more than a little bit. We'll do that, that's probably fine. And then I need a way to mount this to a linear rail. But it also needs to be far away from the actual part that is the rail. So this is already 65 millimeters. Actually, no. I'm thinking about having the rail part of the linear rail be the part that moves. So the carriage is actually going to be fixed onto the other linear rail. And then the rail, the heavy rail, is going to move up and down. Now, that's probably not a good way to do it. I think that might be the way that I do it. So this thingy will be mounted onto a linear rail, and the linear rail will, the carriage will stay still. The linear rail itself will move up and down to, you know, pick up the cards. Now, that requires having a spring or a method to make the weight of the actual linear rail not like be really heavy. Now, I have rubber bands, but like rubber bands are not good for that because they don't follow Hooke's law, right? So I need a Hooke's law spring, and I found something that might actually work for that. It's, you know, those badge holders. I have a badge holder return that has a spring return. Let me go grab it real quick. Alright, I found it. And hopefully it matches the weight of the linear rail. If it doesn't, then I can either double it up like with a pulley, or I can also just I don't know, figure it out. I can add some weight to the actual linear rail itself. Now, how do I attach this thing? Just to test it. Oh. I just would like to see how it goes. Do I send it through somehow? That. I just need to mount it to the linear rail so I can see how well it goes up and down. All right, I just stick the thingy into the. I stuck the because it's a button, right? And so I stuck the button into the linear rail where this is supposed to go, just to see how it goes. Now I'm attaching it with a rubber band. Scuffed engineering? I'm not an engineer, so it's okay. All right, it's mounted. Wow, okay, I think it works. Oh shoot, I put it on the wrong side. Yeah, okay, it holds it up. So I think the linear rail with badge holder combo works. Because it makes the linear rail only a little bit heavier than the badge holder can hold up. Which makes it, you know, it'll be easy enough for a motor to move, and it's not that heavy, right? Now it's a little bit heavier than I would have liked. What I can always do is I can do the pulley like I said, but then I'd have to add more weight to balance it out, and so it's just like a moot point. I think this is fine. This is so silly, but it works. So we're gonna do it. I think this is good. So let me undo this somehow to unwrap the rubber band that I wrapped around the rail. Gosh. There we go. Okay. We figured that out. That's cool. Now I need a spot to mount the linear rail to. So if I plan to have the linear rail backwards, as in like the linear rail is embedded into this thingy, I'd actually need to have it on this side. Wait, what if I use 2 carriages on this linear rail to do the up and down thingy? There's nothing saying I can't just have 2 carriages on. Oh wait, no, I'm just dumb. Never mind. Am I dumb? Yes, I am dumb. I lied. Okay, so here's what we're gonna do. We need this to go, so this needs to go up, right? Let me, can I draw on this? Can I draw on my screen? Is there an easy way to do that? Oh yeah, I know how to do it. We take paint. Here, watch this. All right, we're gonna take paint. I'm gonna take paint. I'm gonna add a, I'm gonna paint bucket it green. Watch this. And then I'm gonna add a filter. Chroma key. Wow. Okay. Wait, it didn't work. Oh wait, it did work. Okay, great. And then I can... Oh, wait. I can't actually see what I'm drawing on because I'm using this... I was trying to use the stream as the thing to draw on, but I can't see it because it's covered up with the big green guy. Anyway, if I draw on it, I use my paintbrush. Wow. Okay. So stupid. Anyway, what was it that I wanted to do? What was I describing? Oh yeah. So this one, I need this to go up. This one needs to go up. When I do the thingy, this one is the one that needs to go up. Wait, is it broken? Oh no, it looks fine. It's just I couldn't see the pixels because of how small the screen is. Anyway. Where'd my music go? Oh, it's just very quiet. That's cool. This is the part that needs to go up, and then this one needs to go down. When the linear rail, when the entire assembly goes down. So I need to have the linear rail be attached on this side. It needs to be attached here somehow. So I don't know how I'm gonna do that. but I believe I want it in the middle, like right around here. So I'll have to figure out exactly how to mount it. Now I'm wondering if like this side, no, this size can fit the linear rail. If this can fit the linear rail, then we're golden. But if it can't, then I don't know what to do. But anyway. Oh yeah, I forgot about that. I can get rid of this now. Don't need that. And then I also don't need this. Wow. That's crazy. I need to get to my this so I can do a thing real quick. Can I mute myself? No, I just have to clutch it out. Okay, never mind. All right, let's copy this. Boom. Okay. Wonderful. Now, what was I doing right now? I got immediately immensely distracted by clicking on Discord. Gosh, all right. Card sorting robot, how wide? It's a 12mm wide rail. So I need, yeah, it'll way fit in there. That's good. So what I can always do, because, so let me hide the other body actually. I can hide body 1 and I can actually just cancel my sketch. Let's hide body 1. No, we need to hide body 1. I can mount the linear rail here. So I can mount the linear rail here, and then at the top I can have a I can like have the badge holder attached there somewhere. I like how I'm using the badge holder because it follows Hooke's law. That's so funny. Actually, it doesn't follow Hooke's law, but it is long enough where Hooke's law is functionally in place in the space that we're looking for. So that's cool. If I use the round, yeah, I mean, you're right. I could, is my chat box not working? My chat box is not. Oh, my chat box is working. It just is super slow. That's great. Does my chat let you send a link? Because I know there's the round rail, right? I'm just trying to get something done as quickly as possible using the materials I have. But I think round rail might be the play in the future, because then I don't need to design, you know, a second linear motion. I can have it all together, right? So I think in the future, I think you're right. I know what you're talking about. I had a 3D printer that used that sort of rail. It's like the carbon rod on the X1C, right? Basically that, but I feel that that is probably a good solution, because then this can be on the rail, this can be on the rail, and then the rail itself can also move up and down. This can just be rubber banded to that. So yeah. Speaking of rubber band, got an old 3D printer. I do have an old 3D printer, except that 3D printer also uses linear rails. So yeah, it's actually, it's what it is it's an old 3D printer from like 2013 that like my school has e-waste days basically, and so like every once in a while they get rid of the old technology by basically just like leaving it outside for students to pick through. So one of the days I found a 3D printer, and like like that 3D printer, it worked like once, and then there's a clog in the nozzle, and then it uses bespoke like nozzle parts, which is a problem. Like in theory, it could be a let me Google mandrel holder. It could be, it basically is whatchamacallit, an E3DV6, but wait, one of these? It uses E3DV6 like nozzle parts, but the heat block is bespoke, and the heat break is also bespoke. And so I gave up on it because I was spending more time fixing the printer than actually printing on it. Now I can just harvest stuff from it. That is very, very true. I mean, like, it has perfectly fine belts and stepper motors and all that. Oops, I clicked a button. Mini CNC. Yeah, I mean, a CNC is roughly what I'm trying to do. That's you buy. I would like to open the link. Oh, that's not helpful. Oh, great. Can I not see the image? There we go. Okay. So something like that. Yeah, that is true. It is basically just that. Yeah. Yeah, that is, so what this part is, this is the part that holds the here, I can draw it. This is the part that holds the card. You can hide this, yeah. Wait, why can't I not see paint? Can you see paint now? You can see paint now. Anyway, so what this is, you have the stack of cards, right? That was a horrible drawing. That was still horrible. You have the stack of cards, right? And then when you pick up a card, it's very likely that you'll have multiple cards stuck together because of air pressure. And so the part that I'm messing about with, this is to separate the cards after it is picked up by the suction cup, which goes into this central area. So like it presses down. It's like a you ever see those machines that like do the sheet metal stamping? It's kind of like how like this the machine presses down on the outside of the sheet metal, and then like the stamp happens, and then it like lifts up in two parts. It's basically like that, except this part bends the card. Like this will stamp down onto the card, suctioning it up, and then it'll lift up. This will stay down, bending the card that you want to pick up and leaving the ones that you don't want to pick up. And so that's what this entire mechanism is for. I think I'm gonna order some I'll order some linear rails and linear bearings so that I can, I mean linear rods and linear bearings, so that I can try that out, because that actually sounds like a very good solution for this problem. Thank you very much, Levin, for that suggestion. That's actually very helpful. I'll write that down in my notes. Linear rod. Yeah, because how most of the card sorting robots work that exist. Alright, I can show MS Paint again. Is that what it'll do? It'll suction it up. It'll suction like a stack of cards up, right? And then at the top, it will have a divider, and it will bend it at the top, and then the card will. It'll bend it at the top, right? And then the cards underneath will fall. And So I'm thinking, and then they have a time of flight sensor, so like an ultrasonic sensor or something, to figure out how tall the how tall the stack of cards is actually, right? So that, but I'm thinking like if I move the entire thing together, then I can use this to probe how deep the cards are as well, because it'll just contact it, and then I'll just have like a switch, right? And then I don't need a time of flight sensor either, because it's all part of the thingy. But anyway, that's the idea behind this. I should order some parts, but what I'm trying to do is just like get a proof of concept so I can see that, okay, this theory does actually work, and then I can make the cause like what if other people have tried this, right? Like what if they tried doing the linear thingy and it just straight up doesn't work? So like, yeah. Anyway, where was I? I was considering how to put a linear rail into our thingy. So we will do that by hiding body 1, and I will put it here. We will create a sketch. I guess on this plane is fine. The unwanted cards are just gonna be sorted and then sold. Like you can sell bulk, but what this really is wait, why did it go beep again? Is it supposed to go beep? I get sounds and I don't know where they're from. I should probably figure that out. But anyway, the cards that we don't, the cards are how do you explain this? No, it's a card sorting robot, right? So you just have the cards and then you sort them, and then if you don't want the card, then you can just like take it to a card store and sell them there, or I mean you could destroy them if you want to, but hopefully, like in theory, I would prefer not to do any damage to any of the cards, but of course that would be tricky to do, and so that's why I have a bunch of bulk to test it with. Anyway. Oh no, here, I can actually show you what I am talking about. Roca sorter in action. Here. Is there a good example of it doing the thingy here? Here.
The vacuum pump.
So you'll see it pick up the card, and then it's very fast. Oh, that's not helpful at all. But you'll see it pick up the card, and then it just bends the card slightly, and the cards underneath fall down. And so basically, I'm just trying to do that. But wait, oh, I hid Firefox. Oops, my bad. Let me unhide Firefox and move it out. Okay, see, if you look in the hold on. Let me get my image in real quick. Wow. If you look here, this is roughly what we're trying to do. You'll notice it goes down, picks it up, and then it bends, and you'll see the cards fall. So that's what we're trying to do, but at the bottom of the bin. So, yeah. All right, let's figure out this how far apart are these holes? 2.5 millimeters. I mean, no, 2.5 centimeters. 25 millimeters. That is. All right, so we need 12. A vacuum system for the woodworking. That would probably be useful. Hmm. Okay, yeah, you'll find them. Thank you very much. Let me get this linear rail. Let me linear rail in here. So how? We'll do 30. Be fine. Actually, you know what? It's not fine. We'll just do it the entire distance. And then I need a spot for 2 M3 screws. Or bolts, I suppose. And they're 15 and 25 millimeters apart. We'll pick here as the first one just for no reason at all. Wait, I shouldn't do 4, I should do 3.5. Or maybe I just do 3. No. Because I'll put a thingy on the other side. A nut, as they say. Yeah, that's 1, 2, 5. Okay, maybe I need to go down. No, but the problem is, if I go down further, then it'll interfere with the other thing. Which is problematic. So I can always just expand this thing. We'll just expand it and then we'll trim it down later. Can I just do this? Great. It doesn't really matter that much. So, 1, 2, 3, 4, 5. 3.5. And then how deep is this rail? It appears to be, we'll just say 10. No, negative 10 rather. Oh, oops. Oh, actually this is fine. Oh, that's not what I wanted to extrude. Why is that selected? Oh, great. Oh, that one's less great. Why is this one automatically selected all the time? That's actually really annoying. There we go. That's fixed. So I will actually just do this. Let's see. Yeah, one of these. I can be in my part. Where was my sketch? Oh, I'm in my sketch. Okay. Now, let me figure out the dimensions of an M3. I really should buy calipers. That's 6. Okay. So let's get the full rectangle here so that, or just like a circle is fine, I guess. There. And then let's get our polygon circumscribed. I don't remember which one was it. It was circumscribed, 6 millimeters. So that would be 3. We're gonna go up to 3.25. That's probably a good number. And then we'll do the same thing here. 10. And then let's get our circumscribed 3.25. And then we'll extrude this section to join. Okay. I should quit Steam. Go away, Steam. Exit. Okay. Where was I? This. Right. Let's cut this in. Yeah, that's probably okay. And then we can extrude it out again. I don't need the sketch anymore. But how deep is a singular nut? It's probably 2.5 millimeters. Yeah. So how far down is this? This is 3. I guess it's fine where it is, actually. Okay, there we go. Actually, here's an idea. What if I made... You know what? What if we called this... Wait, where's my analysis? I can hide this now. So this is where we mount the linear rail. And that's for that. That's for that. How am I supposed to print this? Like, what is the printing orientation for this? Do I have to use support? I guess so. I'd rather not, but sometimes... No, it's okay. I can print it. Right. Okay, actually it's fine. All I need to do is expand that a little bit and make this one lengthwise too. Okay, so let's turn this back on. Turn this one back off. Create a sketch on this face. And it's actually just a rectangular one of these. And this will fix everything. I just do it 10 by some number. That's right, I think. 10 by that. Closest you could find. It doesn't seem to let you send links, but do you think you could send me the title of the video and then I can search for it? It seems to delete the links that you send. But thank you for the help. Also, what happened to my chat? Is my chat fine? Oh, the chat is fine. I was looking at my browser. Where was I? Extruding stuff, right. Okay, let's get these going. -4 or whatever. And then join. Oh, shoot. This will fix everything, and it doesn't. Alright, let's not do that one for now then. But if you see, I'm printing it so that it's in this orientation. So this will be the print bed. And then, oh wait, I forgot that this is not printable. I will have to use support for that, but everything else I believe should be fine. I just need to fix the thingy down there too. So let's just do that. Oh, this isn't printable either. But I can get that real quick. That's not too difficult. Rectangle. Enter rectangle. And then we'll just do this. Finish. Send it down, and then I click join. There we go. Look at that. Wow. And then we create a sketch on this face, but it's just extending this line. That's not helpful. Get a line. Let's get the line from there to there. And then another line from there to there. That'll do it. This is probably the worst 3D modeling anyone's ever seen, but you know, it works and that's what matters, right? That the question is, actually, does it actually work? Oh, I don't need to see the orange. I need to, okay. What if I just printed this and called it, like, what happens then, right? Like, what if I just sent it? Just to see what happens. Like, just to double check everything fits, really. No, I should at least figure out a way where I can, what's it called? What am I trying to do again? Right, I need to mount the badge holder. The badge holder needs a spot for it to be mounted. And then I need to figure out a spot for my switch, the micro switch, wherever that is. Is it in my bin of stuff? I think it's in my other bin of stuff, so I'll have to go get that. 1 second. Alright, got bin of stuff number 2. You just started learning? Well, there's never a bad time to start learning things. What I've realized is that I need to learn stuff a lot. I need to do a lot of learning. Song is playing on my head. Well, right now I'm just listening to what I'm playing in the background, but I don't know what I don't know what I usually like have going on in my head. I think it's usually actually just blanks. Like I usually don't think at all. Like I just run on okay, so like in fighting games there's a term. It's called playing on autopilot, and it's when you're not thinking about like the game, but you're thinking more on like, actually it's just when you're not I'm just running. It's not a fighting game term, it's just a general term. No, I just pretty much always am on autopilot, except for when I'm specifically thinking about something in my mind. That's probably why I'm always scattered. So unorganized. Here's my linear switch. I mean, not linear switch. ADHD. I mean, I tried to get diagnosed one time, but I think they found something else. So anyway, I need M2 for this, and I don't own any M2 hardware, so we'll deal with that another time. Muscle memory. I mean, it's like muscle memory, except it's like, I guess it is muscle memory, but it's like in the sense where it's not like you're doing something repetitive over and over. Like, because muscle memory would be something like you can unscrew a screw with muscle memory, but it's not like you can like, you know, I mean, you can like disassemble your whatever with muscle memory, right? But like, it's more like doing like stuff that should normally be thought out, but without thinking about it, right? Like if you're doing like, I don't know, 3D modeling, and you just do stuff, then 2.5. I don't know if it's M2 or 2.5 actually. It very well could be 2.5. I don't own either, so I can't check. But like, it could be both. What if I just 3D printed a slot that fits perfectly? How's the progress going? I've got this. Amazon? Unfortunately I live in Taiwan. There's not really Amazon here. But I've got Shopee, it's okay. I can order stuff on Shopee, it'll arrive in like 2 to 3 days. It's basically Amazon, but stuff is dirt cheap because I live in Taiwan. Anyway, so this is the grabber. This is the part that grabs the the card. So like the suction cup will go in here, and then the linear rail slots in here. See, and then yeah, I don't know, the linear rail goes in there, and so I'm actually moving the linear rail up and down instead of having it on the carriage that's supposed to move up and down, right? It's backwards, but I think it works better this way because I don't need to have it will be shorter basically and simpler, I think. Now to counteract the weight of you grab your free hardware. I mean, I wish I could have free hardware. I tried. So at my school it's really cursed. There's an engineering lab, right? But I'm not an engineering student, I'm a computer science student, so I can't technically access it. So I went and tried to access it. I went to the engineering office, right? And then I was like, hey, I'm a computer science student. I'm making a card sorting robot for my graduation project. Would it be possible to use the materials in this room so I could do it? And then they told me to go and email not email, but Microsoft Teams. Microsoft Teams, the person who runs the thingy. So I sent that on. So I sent Microsoft Teams, and then so I sent a Microsoft Teams message to the whatever, and then so I sent a MS Teams message. Where was I? MS Teams message, right? MS Teams message to my to the person who runs the room, and then he read it and never responded. So I went and bought my own 3D printer. I went and bought all the material. I printed a Gridfinity toolbox for my I can show you real quick if you want. Here, this is my little Gridfinity toolbox. Hold on, let me figure out how to do my phone. Droid cam, there it is. Then I do this. Wow, that's so convenient. Anyway, this is my little Gridfinity toolbox. Got my stuff in there. Notice how I have M3x12 twice. That's because, oh, that's M3. I also have M3x16 twice. These are button heads. That is the other one. Don't know what that is. Socket? No, that's not a socket. I used to know and now I don't know anymore, so yeah, womp womp. But that's pretty much all I have. This is bin of hardware number 1. You'll notice I have all of these pulleys. Like this is the one that goes on the stepper motor, and then I've got just like random assemblies of just pulleys. This is an electric screwdriver. I don't know what it's doing in my stuff, but the electric part of the screwdriver doesn't work, so it's just a precision screwdriver. Here's solder. Now they didn't have like solder like how you would normally get solder, right? Which is in the spools. They had this, and I'm like, whatever, I'll buy that. Because the problem about Taiwan is like most of the stuff you'd expect just doesn't exist. I also have some M5 hardware. That's for these, because these are M5. Yeah, so there we go. That stuff. Oh, I also have a wrench. Anyway, and then here's my other bin. I have 2 bins. There we go. This bin has all the electronics. So this is you know, the kettle cable. This is the part that the kettle cable plugs into. So I just have a bag of 10 of those. The 10 were the same price as ordering 1, and so I got 10. Fan. I don't know. Here's a stepper motor. See, this here is the is something I designed for Core XY before I changed it to be a linear system, because linear is easier to make. Here's a MOSFET. No, this is not a MOSFET. That's a stepper motor driver. Here's another stepper motor driver. These are TMC 2209s, I think. But yeah. And then here's a voltage regulator. This is for the Raspberry Pi. Yeah, I don't know. A whole bunch of stuff. None of it particularly, oh, here's my, Arduino plus CNC hat. This is what we're gonna be running Gerbil on. I did not design the stepper motor, no. I designed this little white bracket that goes on top of the stepper motor. Imagine designing a stepper motor, that would go crazy. But no, I'm not smart enough to do that. Yeah. Okay, we can get back to doing work. But anyway, yeah. Let's get back to the this. Alright. Yeah, I hope that would make more sense. Anyway, so let's say this one moves up one whatever that distance is, 1 centimeter. M. Watch this. Wow. Did it do anything? No, that's a face. I wanted to move the body. move it up 10. That's how far it will get. And so we need to make it so that our thingy switch, I don't know, what is this thing? Actually, you know what? That's not gonna work because it just won't. What if I here's what we're gonna do actually. We're just gonna extrude this in a little bit. Minus 7.5 I think is a good number. And then I will add mounting holes so that I can design the part that, you know what, I'll do that here too, minus 7.5. Because I don't actually need it to be that big. I will add holes for me to screw the stuff into. The switch. I'll add holes for the switch to screw into. I can do English. Yeah. No. Yes. Yes. That. Okay. Yes. I'll add. Oh my gosh. I will add holes so that I can make a plate that this switch can mount into, so that I can adjust where it goes, so that I can change where the trigger position is. That is what I was trying to say. So I think I will make some holes. Let's just add like 4. Let's do one here, 3 millimeters, and we'll do one here, 3 millimeters. And I'll do one here, 3 millimeters. And I'll do one here for 3 millimeters. And then let's just add some more for good measure. Why not, right? 3. Actually, wait, hold on. We're gonna just have them each be 1 centimeter apart so that I don't need to think about it in the future. Oh. Because I don't know what I'm gonna do. So we're just gonna make it so that no matter what I do, it'll be okay. Enjoy the coffee. You like the idea of the project? That's good. I really want to get this project like good, because let me explain this well. How do you explain things? Because my biggest gripe with the card sorting robot like scene's not really the right word to describe it, but like the card sorting robot meta, that's not the right word either. But the card sorting robots that exist right now are really expensive, like upwards of $1,000. And for, I believe, like $300 to $400, you could build a robot yourself and it would do the exact same thing. And so that's the entire reason why I'm doing this. I want to make an open source card sorting robot for anybody to be able to just download the files, print it themselves, slap together some electronics, because I'm not an electrical engineer, right? And so if I can do the electronics for this project, that means anyone can do the electronics for the project, right? I'm not a mechanical engineer, but if I can make the mechanics for this project, that means anyone can make the mechanics for this project. So I'm just trying to make the most accessible possible free open source card sorting robot I can. And that's my goal with this. So let's extrude these a little bit. How about we do minus 20? Is that gonna break anything? It'll break some stuff. You know what? What if I just did minus the entire thing? What happens then, right? Nothing bad happens. Oh, there does something bad happen. Never mind. And it happens bad there too. Okay. Never mind. We're not gonna extrude it the entire way. We'll do minus 12 or something like that. Or we'll do minus until it interrupts one of the things I need it to not interrupt. So like here. I think this is good. Yeah, that'll do it. Okay, we'll go back 1 because it's being annoying right there. Actually, we'll go back 2. You know what? We'll do it minus 15. That's a good round even number. So there we go. Actually, you know what? We will cut this one all the way. And I'll cut this one all the way. I'll give it that. Because then I can screw it for as long as I need, well, screw it in for as long as I need to for it to work. So let's get those. There we go. There we go. Alright, let's print this thing. Yeah, I agree that open source is the best possible solution for pretty much anything. And that's why I'm doing what I'm doing. Alright, now we need to rotate this so that it prints in the right direction. Then I need to add supports. Manual. And then how do I do supports in this software? There it is. I would like to just fill here. Slice, let's see what happens. This is PLA. PLA is good. I wanted PLA. Okay, it'll take an hour and 11 minutes. I might as well start it now then. I gotta go and change my filament first though. So how about we do this, and then I do this, and then I do this, and then I write something here. Big red paint bucket. This is gonna be a recurring gimmick on this channel. Alright. See you later in like 2 minutes. Okay, I'm back. Okay, so the reason that I am specifically printing in this orientation is because all of the overhangs are printable. I arranged everything so that every single overhang would be easy to print on the printer. If I were to make it even easier to print, I would cut some slots out there, and I actually will, because it would help make it like much easier. How do I rotate things? There we go. I remembered now. Sketch. So if I make some lines here. Okay, is it gonna be cringe? It is gonna be cringe. So we're just gonna do it the cringe way. How about I extrude it to here? There we go. There we are. Yeah, because if I print it in this direction, then every single overhang can be printed without support, except for this one for the linear rail. Let's delete the old one. Yeah, those really big round overhangs might have been a problem, so that's why I just got rid of them. Yeah, it's something that I always keep in mind when I'm designing something that's printable, is how am I going to handle the overhangs? It's always in the back of my mind when I make something. And so I usually end up with designs that can be printed with the least amount of support possible. Now, I don't know why it's being cringe. Makes it so the holes don't need support. So basically, for this one, if it's small enough, the gap, it does not need support. And this gap is small enough where it doesn't need support. This overhang will be fine on the printer, and this fit will be fine on the printer. You see, it's something that you kind of just have to like get. I don't know how to explain it that well. But you see the blue spots is the part where it's technically supposed to not be able to be printed. But here you'll see that that is just like that tiny little point, and that's good enough. And then over here, it's kind of like a size versus angle. You have to think of the size of the overhang along with the angle of the overhang. It's like this will be fine because one, it doesn't need to be pretty. Two, it's not that big, and that's really it. It's just round things. I don't know. It's really hard to explain. I'm sure there's someone on the internet, like if you go and watch a 3D printing YouTube channel, then they'll explain it better. But yeah, it also, as Almond says, it also depends on the printer you're using. My printer is fairly good, so I can get away with a lot. But like if you're using like an Ender 3, it might be a good bit more difficult. Because I've got, this printer has like, it has a side fan cooler as well as an insanely loud nozzle cooler, so yeah. Oh, I need to click the OK button. 1 second. Oh, you're using a K1C? Yeah, with a K1C you can get away with a lot because it's just a good printer. Here, how about we start it? I think that's good. Also, I can do the thingy that I was doing earlier. With the yeah, it's kind of wild how much better printers have gotten over the years. I started getting into 3D printers in, I think, around 2017, 2018. I had a Monoprice Select Mini version 2. That was my first printer. And like compared to today, gosh, that thing is so bad. The heat the hot end cooler and the print cooler were the same fan, which meant you can't actually like control how much cooling you're giving to the print. And then like it was just tiny and not reliable. That's the printer that I used to make my 3D printer music, if you have seen any of those videos before. I can show this. Wow, look at that. That's Firefox. Incredible. Boom. All right, and now we let that go. You're gonna hear the fan noise in the background, so hopefully that's not too miserable. I can put something in front of it to make that reduced a little bit, so let me go do that real quick. Yeah, Mons is right. There are the you can do a torture test for your printer just to see exactly what sort of thing you can pull off. My general rule of thumb is that if it's round, you can probably print it without an overhang. It might be ugly, but it'll probably work. This hexagon is stretching it. Like this angle is stretching it. That's like, I'd consider that like any more than that, and it's probably not gonna, might not turn out that well. But like, yeah. So an Anycubic Mega, I don't remember that. It sounds very familiar. I had an Anycubic console that I got for free from Facebook Marketplace. It arrived, they said they couldn't get it to work. And it arrived with a control board. Well, the control board was fine. I still use a control board, but the LCD, the LCD, the LCD like potentiometer, not potentiometer, but you know the little dial that you twist and it goes click, click, click. That one, it was busted, and the power supply switch was set to 200 and whatever it is instead of the 100 and something that the US uses. So the holes, these holes are only oval because it's a circle at an angle. They'll technically work. I mean, they'll work because there's not actually an overhang. It's just printing the wall up. I can show you in the slicer. But if you look here, the overhang is fine, because that's not really an overhang. That's just printing a wall basically, and then it just connects the wall. So that's why they're perfectly fine. I'd say the sketchiest part is this circle. The hexagon will be okay. The see, there's the hexagon. See, that's perfectly fine. This is the only part that needs support. Holes? Which holes? The main circle? It's not. It's just perfectly round. So an hour and 9 minutes and we'll have our part. That's nice. It's so crazy. The biggest change for me is going from a printer that's slow to a printer that's fast. All of the circles you see are circles. They're all perfectly circular. But yeah, the biggest change for me for the new printer is just how fast it is. I went from having to design a part, print it overnight, and see if it works in the morning, to being able to rapid prototype literally real time. And that's just insane to me, right? It's like, Wow, you couldn't used to do that, but now you can. So, yeah. Anyway, there is a part that I forgot to add to the thingy, but it's okay. Let me show you. So this has no way to return back down. It needs a spring. And so what I can always do, I can just have on this plate that I'm gonna make, I'll attach a thingy there, and then this one I can just expand, and then I'll have a hook. And then I'll just use a rubber band to make it go down, and that'll do it, I think. Or maybe it'll be better to have it hooked there, and then here I just have 2 screws and go down. I think I will just do that, so that's easy enough. I mean, heck, I can even just make some screw holes on this and just put the screws in and then just use those. It does not need to be that complicated. Or, I mean, I'm gonna be printing it in this orientation, so you know what we'll do? I will just create a sketch here, and we'll just, like... I will just do this. Where'd it go? Oh, I have my sketches hidden. Minus, we'll go with... Yeah, that's probably fine. 5. Sure, we'll call it 5. I really should have just put circle, made it a circle, but oh well. There we go. Wow, look at that. That's so nice. But anyway, yeah, this is where our rubber band, we'll just have the rubber band, and then here we can just have some screws, and that'll help push this part down. If I need to, I can do it on the other side. I'll just drill some holes or something. I don't have a drill though, but I can do that. I like how I can have the live stream in the corner of my screen. That's great. Wait, what? I just checked my PayPal. Are you sure you actually intended to send that? No, that can't be real. Wait, what? I just saw it on my phone. No, I don't have a drill. Well, this can go to my drill. Thank you very much, Levin. That's crazy. Go get me a drill. Guess I gotta get myself a drill. No, that's nuts. What do I do? Like, I don't know how this works. Like, what do I do though? Because I never expected for anyone to send me anything, let's be honest. Shoot. What do I do? Well, thank you very much, I suppose then. That's the least I can do is thank you. So, thank you. Where did I put my stuff? I had it... There it is. Open source. Well, it will be open source. Heck, you could build one yourself if you want to. Maybe I should write open source in the title. Oh, thank you very much. I appreciate it. I don't know how I should put that, but thank you very much. So I need to add some tolerance for these. I believe I can just press pull there. Minus 0.3. Think that'll do it? I'd also need to get this. Oh, that's the part I'm printing, actually. I can't do that. But I can do it on the other side, so that's okay. We can hide body 3. Press pull. And, you know, wait, hold on. What is going on? In a way, you have a guarantee that I won't just run away with the money, because this is my graduation project. I have to get this done, otherwise I'm not graduating college. How do I grab multiple faces? Can I grab them this way and then press pull? Yes, I can. Okay. And then we'll move it to 0.3. No, that's not what I wanted. I wanted to press pull. I press E because that's extrude, and it's just instinct, right? Press E. Minus 0.3. Well, thank you. I'll be streaming a lot over the summer, so you can watch my progress as I get the project done. It is a group project, so I have some friends helping me with the software, even though that's technically the part that I'm supposed to be, air quotes, good at, because I'm a computer science student. But like, my goal, I want to take this to open source. I don't know if you know what open source is, but William Osman is one of my like biggest role models is William Osman, and I've always wanted to go to open source, but I've always been either busy or like the timing is bad, or I just don't have like the funds to do it. Well, I mean, not the funds, but I mean, I would technically have the funds. It's just completely impractical. Press pull the same. I don't know what SolidWorks is. I don't know SolidWorks. I will definitely take this thing to open source once I'm done. Press pull is a very useful tool. It does a lot of stuff. Like if I wanted to press pull this, I can make my thing smaller. Wait, Mons, we should meet at open source. We should absolutely do that. I can fill it. No, I will chamfer this and this 1 millimeter so that it's printable. 1. Because I've been following William Osman since, I guess, around when he started making his videos. So like 2017, 2016, and it's just like he's by far my favorite YouTuber. And it's like, I feel like I gotta go, you know. Alright, I need to fill it. This. I need to also add that. Oh, that fixes it. Okay. Then I grab this too. There we go. That works. That's what I was looking for. You're going to bed? Well, I hope to catch you again. Because, well, I guess. Yeah, I just hope to catch you again. Don't really need a reason. 2 a.m. Ah, East Coast time. I'm very familiar with the East Coast time because that's where my grandparents live. Well, I'll see you again. I will not be streaming tomorrow because tomorrow I have work, but the day after tomorrow, meaning what is that? I don't know. I'm so bad at days. I don't know. The day after tomorrow, I'll probably be on. I'll just have to be up in the morning. But yeah, I'll probably be on for a while. So yeah, I'll see you again, hopefully. Because it was very helpful having you here for conversation. Do I need to fill it there? No, I don't. There we go. Since his house burned down. Yeah, I remember that. I liked his laser videos. I need to also grab that one. I forgot. You subbed? You'll be back? Great. I'll see you later. I'll see you later. Once again, thank you very much for the donation. Now, the problem with this is that actually this is very weak, because this is the printing along the layer lines. So actually I imagine that'll fail eventually. So I should actually go into here and change it such that that's better. This feature is for the rubber band. So basically, this section, not that one. This body needs to be able to move up and down, right? And so it needs to be able to press down with an amount of force. So these are hooks for rubber bands, and the rubber bands will, I'll have like a slot, like I'll have screws in here and I can just put the rubber bands in there, and basically it can go, it'll be a force downwards basically. So that's what I need it for, so that it can bend the card. And yeah, that's actually it. That's it. I just need rubber bands there pretty much. And so it needs to, it can't be weak, and it's also gonna have a repeated amount of like force on it, so I need to, you know, make it not the weakest thing ever. So yeah, this will mount onto a linear rail, and then that linear rail will mount onto a carriage that's attached to this linear rail. I might move this linear rail to the top, because then I can have the carriage on the side, and I think that would make sense. I could just make it a hole, you're right. I mean, that's the better solution. You know what, we will just make it a hole. Wow. Bye. How do you delete? Oh, okay, there we go. We're just gonna make it be a hole. You're right. Overcomplicate things, and then it just doesn't work, and then you're like, I wonder why it didn't work. We're gonna do a 3 millimeter hole here. And a 3 millimeter hole here too. There we go. Wow, that was so much easier. Who could have imagined that? Sure. Wow, what a feature. I can still fill it with this though. I can also make it big. Wow, that's so cool. 20. We'll make it be 20. That's a good number. Oh shoot, my Firefox froze. Fixed. I love how this stream went from being my worst stream like ever to being one of my most successful. It is my most successful here. It's wild. I started out like a bumbling idiot. Like I did not have a single train of thought running through my mind, and here we are. Yeah. So the Levin had the idea to basically like, what was it? Basically, instead of a linear rail and then like having this slide on the print, basically I just use linear rods, and I can have two sets of linear bearings, right? One for the top part, one for the part that goes here, and then one that goes here. And so I have to order that. I'll do this for now, but like I'll order the linear bearings and linear rods because that's just a better solution. I was just too like in the trenches of like, hey, linear rails are good and cool and easy, except they're actually making my life harder. If I used linear rods, my life would be easier right now. So yeah, we're gonna switch to linear rails for linear rods for this assembly. Oh, I forgot. I need a spot for the what's it called? The belt. That's kind of important. Well, I can put that on this mounting plate. I can have a belt on this side, and then on this side I can have the how do you do words? This side can be the switch. Not switch. Mont, you'd probably know better than me. Should I go for Drylin bearings or should I do like normal linear bearings? Like imagine Drylins would be easier to work with and lighter. But like they might just like not work. I don't know, because I've never used Drylins before. I'm definitely gonna take this card sorting robot to open source. I had another idea for a project that I wanted to make. It was a it's a what's it called? Oh gosh, I should like. It's like I went to college and I got dumber at college or something. But like, oh yes, it was Bad Apple, but played on Great Ball Contraptions. You know Great Ball Contraptions? They're the Lego contraptions that like have the marbles roll down them, and then they do weird things with the marbles, and then like the marbles run around the table basically, and everyone brings like their own machine, and then the machine like has an in bin for the marbles, and then it sends the marbles to the next person's out bin, and it's a bunch of different, there's a bunch of different methods to move them. I was thinking, what if I made a Great Ball Contraption robot that played Bad Apple? Because there's two colors of the Great Ball Contraptions, right? There's the orange and there's the white balls. So what if I played Bad Apple using, you know, white as white and orange as black, right? I'm like, that could cook. And like, you know those, so recently, a bunch of YouTubers have made what are they called? A bunch of YouTubers have made like marble art machines. And the idea is basically the same as that. I came up with my idea before they posted them, I'll have you know. But marble art machines basically, where they like sort the colors and then they send them up. Except the way I would do it for mine, because I have to move the marbles through, right? So the marbles have to go through like the track, no matter what, right? So basically what I was gonna do, I was gonna have a really big in bin. Marble clocks, I have seen the marble clocks. They're nuts. It's crazy what people can do when they have sponsor money. I'm just kidding, of course, but like I was gonna have like a really big in bin. And then with this in bin, I would just send up one marble at a time. Not like, obviously it would be faster than, but like it would just be like I wouldn't have a separate bin for each color. I'd have a bin that goes, all of the colors go into one bin. And then at the top, I'd have a color sensor, a color sorter, right? And so if it's, what I'd do, I'd have the array of marbles, that's the displayer, right? And so the marbles go in one at a time, right? So up, right? And then what I was gonna do is basically if the marble is correct, if it's a correct color marble for the next slot, then I could make it so that it's it goes in, right? And then if it's the wrong color, it just sends it through the marble run, right, to the next machine. And that way it's like participating in the great ball contraption while also just like doing the thing. Now, because great ball contraption machines have to have an output of 1 ball per second basically. And so what I'm thinking, yes, there's the Lego Mindstorms EV3 color sensor, and so I was gonna use that. It's been done before, because there have been like machines that sort and then send it through. But the way I deal with the issue of having to comply with the 1 ball per second is that I'm going to basically have the bin be real big for the in bin, right? And then every single time I make a frame, I send that frame back into the in bin, and then I can sort at a rate, I can scan the colors at a rate faster than 1 ball per second, because the in bin will be receiving balls at 1 ball per second, and the out needs to be at a roughly 1 ball per second, right? And so I can be receiving the balls at 1 ball per second while sorting the balls at like 2 balls per second. And then I can be and then if I'm rejecting them faster, then I can have it, instead of, you know, going all the way, instead of going to the next machine, it can just put it back into the in bin. But if it's slower, then, you know, then I have to speed up the sorting. And so there's a balance that I need to make. And I think it'll be a really fun project. I just don't have enough money to do it. No, I might have enough money to do it, but I don't have the materials to do it. Meaning I don't have any Legos in Taiwan. I don't have any of the all the stuff that I need to do it is in Washington. So yeah, it's not the most practical project right now. Once I graduate and have and I'm unemployed and whatever, yeah, if I start with a bunch of balls in the in bin, I'll be good. Or if I can just like have it like be like 75% of the 1 ball per second until it's full, and then it can go to 1 ball per second. I just basically need to become like a little bit of a ball gremlin for a little bit, because I think I did the math. Each frame would have 400 or so pixels. Less than 400, but like, because I did the math forever ago, but like 400 marbles is roughly what I need to have in each frame for it to look good. So, but yeah, I'll make Bad Apple on a great ball contraption. I think that'll be my, and then I think OpenSauce has a great ball contraption, so I could put it into the thingy. Or if OpenSauce doesn't have a great ball contraption, they should definitely have a great ball contraption. I'm sure 20 by 20. Well, it's not 20 by 20. It's because it's it's 4 by 3, right? But I believe the math I ended up doing was like times like 3 or something. So it would be like 16 times. Let me open my calculator actually. So I think it was like 16 by 12 or something. No, that's too small. So let's go up some. What is 16 times 12 times 2? So that would be 32 times 24. That's 768. I'm not good at mathematics. No, that's squared, not times 2. That's to the power of 2. 32. Okay, how about we do, what was it, 16? So let's do 20 by 15. 20 by 15 is 300. So let's add one more 4. 24 by 18 is 432. So it was somewhere in between that like rough area. I think it might have been the by 15, but that's cringe. Oh, wait. Or maybe it was, oh, it was probably 20 by 16. Yeah, I think 20 by 16 was right. Wait, because I think the reason why I came up with that number is because the Lego base plate is 48 by 48. And so 48 divided by 2, wait, that's not 16. That's 24. I don't know. I figured it out at some point in time. Maybe it was 24 by 18. But basically the idea was that I could just use a base plate as the thingy. It doesn't really matter because I can't work on it right now, so. But yeah, it was gonna be Bad Apple on the whatchamacallit thingy. I had another idea for a Bad Apple video. I was gonna make a like, you know those like water droplet machines where if you 48 divided by 3 is 16. That's true. But each ball is basically 2 studs. So each track for the ball is 2 studs wide. So it would have been 48 divided by 2. But anyway, my next idea for the Bad Apple video was, you know those water droplet machines where it's like the floating water droplet because it's the strobe lights? It's lights that strobe, right? And then there's like a water droplet and it floats. Ooh, so cool. So I was like, well, if you had greater control of the water, couldn't you like draw a line using, you know, a strobe light and the water? And so if you could draw a line, then couldn't you draw a bunch of lines and have a bunch of different line lengths? And then doing that, you could maybe make an image on falling water with a strobe light? Right? And then it goes to, what if I played Bad Apple on falling water, strobe lights, water floating strobe light water machine? Right? Wouldn't that be cool? That would be cool. But it's complicated because you have to time the water so perfectly. I don't think I have the smarts to do that. I don't know if water solenoids, like solenoids, would be good enough to do that. You'd have to have pressurized water so that it moves fast enough. And then it becomes like a real engineering like nightmare, and I'm not smart enough for all that, so. Shoot, I just realized I might be cooked. That's 12 millimeters. Yeah, you need to sync the water refresh rate with a strobe light. Yes, yeah. But like, that's software. Software's easy. And then the camera speed, what I was gonna do for the actual video is, actually it's not even, well, it is software, but like you just like, you can just use a potentiometer and like the capacitor thingy and just have it flicker. But like, The camera speed, what I was just gonna like basically do it stop motion. Just plug in one frame and then plug in the next frame and then plug in the frame after that and just see what happens, right? But like if it is easy, it might just like work. I don't know. And who knows, I might not even need the strobe light if I can control precisely like the frames per second of the camera, right? Because you can do the floating water droplet trick without needing a the strobe light if you just use a camera. So I could just do it like that. But then again, yeah. Well, we'll let this finish. It's like most of the way done anyway, so. I did select PLA, that's good. So we'll see. I do have sandpaper, so I can always just sandpaper it up. Yeah. Dang it. Where was I? Fusion 360. Alright, what else was on my agenda? Bin. And maybe a camera round. We'll do the bin. So this is the bin that I came up with yesterday. Like, it does the job, except there's a... You gotta head out. Alright, well, I'll see you later. Alright, thanks for the good luck. I might or might not need it. We'll figure it out. Just sketch here, though. You can always check the VOD to see how it goes. These slots are so that you can pick up the cards easier. Because, like, then you can just, like, grab it. Without the slots, it's a bit more difficult. Let's see, how far is our printing? 35 minutes left. Halfway done. Cool. Where was I? That's OBS. Don't need OBS. I need Fusion 360. There it is. I figured it out. Trust me, I got this. Wow, now that no one's watching, I can take a break. I'm going to sit here and I'm going to drink some water. Maybe I get a boba. I like boba. Alright. So this is the bin. I think this is fine. This will be fine for the bin. We're gonna just save this one. But I need to make another bin. And this bin is not for the human. This bin is for the robot. The point of this second bin... Hold on, let me figure out how big I need to make this thing. $75 by 100. Okay. The point of this second bin is to keep the light out. Now that might sound weird, but if you look here, this hole is for a here, let me move this. Let me move the bin. Can I click this and then press move? No. Okay. How do I move this then? Oh, there it is. I still can't move it. Unground from parent. Now what if I moved it now? There we go. Okay, 75.25 I think it is. No, maybe it's 77.25. No, maybe it's 70. How long is this? It's 75 plus this. 1.25. Okay, I was close. No, I don't want to move that. I want to move this. Move my component, please. No, that's not. There we go. 75 plus 1.5. No, 1.25. There we go. So if you look here, there's this round circle. I'm starting with the CAD because the control software is in a way the easy part. Because actually no, the reason why it's not the easy part, it's the hard part. But the reason why I do it is because I'm doing it the CAD first is because I feel that it would be easier for me to make the control software if I already have the physical thing in my hands. It's just the way my mind works. I couldn't start working on this CAD without buying all of the material first. It's just the silly way my brain works. I don't know. It's like I can imagine like how I would want the mechanism to work, but I can't actually start making the mechanism without having the materials in my hand first, if that makes any sense. Yeah, but the CAD software in a way, because there's already another group working on the exact same thing, an open source card sorting robot. It's Moss, it's for Magic. But I imagine I can, because they're pretty open about it, right? I can take inspiration from the way they solve some issues to help solve some of my issues. And I'm sure they'd be okay with that. I mean, I haven't asked them, obviously, but like the software is fairly easy to imagine how it'll work. Now, of course, will it work exactly that way? No, but you know, I mean, yeah. Besides, I haven't gotten my Arduino set up yet. I haven't gotten my Raspberry Pi all set up yet. So there's a lot of stuff to be done. I just want to get the CAD out of the way first, because a lot of the issues that I have along the way will probably be hardware related, and so it's easier to solve the hardware issues if, you know, I have the software like detailing what the issue is compared to like design. I don't know. It's really weird. But anyway, so the thing about card sorting robots, how everybody else does it. I'm being quirky and special. Now I know you're not supposed to do that, but the way I'm thinking about solving one of the big problems with the card sorting robot, which is taking consistent pictures, right? A lot of the times people will have the camera on the gantry, and then it'll go down, take the picture, it has a light ring around it. But the way I'm going to do it, I will have the camera facing up. I'll have a light ring around the camera facing up, and then I'll have a bin here, and this bin will be empty. It will start completely empty, but that's okay because of the way my sorting algorithm is gonna work. I detailed how that will work in the earlier stream. I should probably clip that so that I don't have to explain it every time. But basically, I can use quick sort to sort at any number of bins using only 2 empty bins. And so one of the empty bins to start will be the camera bin. Now, because the camera bin will be empty, I will be able to pick up a card from any other bin, drop it in. Not drop it in all the way. It'll be held up on the suction cup, right? But I can take a picture of it from the bottom, and then that way I have the semi-exact lighting every single time. The problem is that I need a bin that lets no light through, but it needs to let air through. It should be fairly simple, after all shutters exist, but like, you know, I just need to do that. So that's what we're doing here. Move this up 5. I'm gonna do a chamfer here so that it interfaces with the bin. And then we'll do this. Pretty much the same thing I was doing on the earlier one, except I'm instead gonna make the side gap larger. How many was that? 3. This is 3. And then I believe I did 100 for that one, so we'll do 100 for this one. And now I'm gonna make the shutters. Now there's probably an easy way to do this, so we should figure out how to an easy way to do this. I do want to be able to see through this thing though. Okay. So, because if you look at this bin, hold on. If you look at this bin, it has these just gaps on the side. That's so that you can lift the cards out after they're done being sorted, right? But this one, hopefully no one's grubby little fingers will have to go into it. So, yeah. Anyway, where was I? Where was I? Shutters, right. Alright, let's draw some lines. I think just 45 degrees will be fine, probably. And how about we make them 2? Sure, let's do that. Rectangular pattern eyes these guys. And then I would like to move it to the extent of... Wait, that's not what I'm trying to do. I want to make it go minus 90. Yeah, sure, we'll call 90 good. And then we just need to increase the number of them. How about we go with 20? Think that's good? Seems good to me. Now, hopefully this blocks light. I mean, I don't see why it wouldn't. I can't... Oh, that's not what I wanted to grab. This is a very bad idea. I should have extruded it and then cloned it, but alas. Wow, look at that. Oh, yep. That'll do, I think that'll do. Actually, hold on. There's one more that I wanted to make. So how many millimeters is this? .737. That's not a very good number. Alright, how about we undo all of that? And we choose a different method of doing the pattern. No, I don't want to get that line. I want to get the short line. Oh, I don't have a short line there. That's okay. Spacing. We want 20 of them. And then how about we say the distance is 5 millimeters? Okay, maybe the distance is negative 5 millimeters. Okay, why are we getting 3 and not 20? Oh wait, that's the wrong one. Wait. This one, we want 1. This one, we want 20. At negative 5. I think this will do. Now you might be like, hey, but that's doing the thingy. It's okay, because that's only gonna matter for like the bottom, like a few cards, and there's gonna be a big gaping hole for the camera. That's okay. That's like that. I mean, all these need to do really is just let air go through them. And so that's our goal. There we go. Wow, look at that. Incredible. Now, this should be no, it's not printable. It's way too long to be printable. So maybe I'll just add a column in the middle and then it should be printable. Yeah, let's add a column in the middle. How about we mirror it first though? No, not an offset. We want a plane, a mid-plane. That's good. Let's get one there and there. And then let us mirror. You know what? We will mirror it after we add the column. So let's make a column real quick in the middle. How about that? We'll do this. That sounds like a good size for a column. And we'll extrude this. Now it's gonna think I want to cut it. I do not want to cut. I would like to join actually. And then I don't need this, so we can just get rid of that. Bye-bye. Okay. Like that, surely a printer can bridge that. That'll be fine, I think. Let's mirror this. I would like to mirror my features of this. And this. No, not that. Look at that. There we go. Oh shoot, I just realized it didn't actually do anything. There we go, that's what we were looking for. Okay. And now we just make a big hole in the middle. Big hole. Just make a 40 millimeter hole, I believe is the size it was. But we can double check in our frame v2. This hole, 55. So we will make a 55 millimeter diameter hole in here somewhere. 55. And let's add some tapers because I mean chamfers. Chamfer, taper. Chamfer. Yeah, one there, one here, 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 one here. We're gonna say 2.5, I think. That's what I did for the other bin. 2.5 is a good value. As well, wait, am I allowed to do that? I am allowed to do that. Then in that case, I will do that. Grab that and that. Cool. Alright, I think that'll do it for that. That was pretty easy. See, now the light cannot go and bounce onto the camera, but yeah. And then the light from the light from the camera also can't go out into the world. But I think that does the job. That does the job right there. I like that. Okay. Now we can import it into here. Oh wait, I gotta save this first. Call it bin. Cam bin. And then I also have to save this one too. Grabber. Alright, I need to get this to be in here somewhere. I don't know how to match it up the easiest, but you know, this is close enough, I'd say. Maybe not close enough, but it's close-ish. It's definitely not centered. I think it's -3 plus 1.25. No, that was wrong. That one's still wrong. Shoot. Let's do it. .25. This right. That looks right to me. Okay, what about the other direction? What if we called that certified good enough? Oh wait, it's not certified good enough. Well, you know, for our purposes, it is good enough. It does not need to be perfect. Alright, I want to see how much time is left on the printer. 12 minutes. Okay, once that's done, we'll take that out, and then I think that'll be enough for today. I don't know, because I don't have the LEDs for the camera, so I need to order those, and I also need to order some M2 or 2.5 screws. It's probably both. And then I also need to order some linear rods and linear bearings. I'll probably do dryland bearings, dryland bushings actually, because it's easier to deal with. But yeah. Let's see what else. I don't know, or maybe I just end it without having the print finished. Ha ha ha. And here, let's see what else is in my notes to do. Here's in my to-do list. Camera mount. I mean, could I do a camera mount? I don't know. I think we're good for today. I think today was a pretty successful day. We got our grabber somewhat modeled. We left this plate here for testing, but yeah, it's pretty much done. There definitely are some parts where more attention needs to be paid. For example, where do the belts go, right? Belts are a little bit important. I mean, yeah, I don't know. Drink some water. I clicked a button. Oopsies. Let's go that. Get rid of that. And let's get back there. Okay. I think we're done for today. I don't know what there is to do. Tomorrow, I have work. But the day after tomorrow, I will work on the camera mount. And I'll do the, I'll probably do the grabber again, just a second time. Just redo it to make it better. Wow, I printed this way too early. There's a whole bunch of stuff I forgot to add on to it. But so that's okay. Well, thank you for watching. Unless, can I just goof off for another 10 minutes? No, I am not goofing off for another 10 minutes. Okay, thank you for watching. Let me get into my Microsoft Paint. Which one are we? This one. Boom. No. Boom. Yes. Okay. Let me draw something real quick. Thank you for watching. I'll see y'all later. Catch you again sometime in the future. Yeah, as in like in 2 days.